Alright, AT. So we're going to talk a little bit about piecewise defined functions. So you are supposed to have tried the first few problems and then started watching the movie. If you have not yet, please pause this and go back and try to answer how much would you pay for 30 minutes, 3 hours, 5 hours, 8 hours, etc. If not, if you tried it and you're not sure, well, we'll go over the answers are either way now, and then we will talk about what the heck is a piecewise defined function. So for this one, if it's 30 minutes, well, 30 minutes is definitely less than 2 hours, so we would pay $23. Alright, so if it's 3 hours, we got to figure out where 3 hours fit, so 3 hours is between 2 and 4 hours. That should be $35. And then what happens if it's 5 hours? So at 5 hours, we've already gone through 4 hours, so that's $35. And each additional hour, so 4 hours gives us $35, and 5 hours is just one more $20. So plus 20 would end up being $55. Okay, now how about 8 hours? So 8 hours, we have 4 hours already went by, so that's $35, but then there's another 4 more hours. So plus 20, but times 4, well, 20 times 4 should be 80, so 35 plus 80 ends up being, well, 5, and then 3 and 8 makes 11, so 115. But this one's wrong, because we have a maximum daily charge of 100. So somewhere between, 7 hours won't be quite over 115. I think it's actually 95. And then 8 hours, we end up jumping over that $100 mark, so we won't actually pay 115. We're at our max, so the maximum value would be $100. And then one of the things that's tricky that we got to kind of make happen at the bottom is what's tricky about 2 hours. Well, 2 hours actually ends up in 2 spots in here. So 2 hours is here at $23, and 2 hours is also here at $35. So kind of depends on your definition, and if you were exactly 2 hours, I'm not really sure how that would happen, because you would have to magically get to handing in your ticket at exactly the 2 hour mark. But 2 hours 1 second, 1 hour and 59 seconds. So 1 hour and 59 minutes and 59 seconds, the likelihood it's actually 2 hours in reality is so slim that you don't have to worry about it. But I think it would be under 2 hours you would be paying that $23. And then the second you hit 2 hours and above, it would be $35. But it's tricky because the sign is not clear about what happens at 2 hours. So we've got to be a little bit more careful. So if we were going to program this into a computer so that it would charge you and you wouldn't have to actually walk up to somebody. So this is one of those things where the computer wouldn't argue with you. They just charge you $35. Whereas a person, you could be like, hey, it says 2 hours. And you could try to hand them their ticket and maybe you'd be able to have an argument with them, but not going to argue with the computer too much, because the computer is going to end up having something called a piecewise defined function. So I'm starting with this example, and this is not in your packets, but I'm starting with this because a lot of you guys are just starting to drive. Maybe your parents still pay for all the parking and all that, but this is something you'll see if you go down to the city. Not so much equations per se, but that each additional hour, that actually is an equation that you'd need to write in order to figure this out. So how would this look? So for a lot of it, it'll look just like it does on the actual parking fees thing. So the first part in writing a piecewise, you got to realize that there are different pieces. The first piece is from 0 to 2 hours. The next piece is from 2 to 4 hours. The next piece after that ends up being from 4 hours to 24 hours, for that full day, and see kind of what happens on that. So let's try to write it. So we'll start with the easy one, 0 to 2 hours. So our cost is going to be $23. So then there's 2 parts to a piecewise defined function. There's the actual equation, and then there's a when does this equation work? So this works when x is between 0 and 4. 0 and 2, sorry, I lied, not 4. Now, there is a question about, does 0 actually count? It's like, should I have this being less than or equal to? Do I count 0? Well, I would hope not. Like, if you were really at the parking lot for 0 minutes, are they going to charge you $23? Like, if you accidentally, like, just ended up in there and realized you're not staying. So in the first minute or so, you should be able to escape without having to pay. So I'm not going to put the equal to sign on the 0. I'm also not going to put the equal to sign on the 2 because up until 2, you're going to pay for 23 hours, $23. All right, so then 35 would be the next part. So we would pay $35. Still on the eraser. As long as x is between 2 and 4. So our time is between 2 and 4. But now we're going to be a little bit more precise. So if it happens to be exactly 2 hours, I'm going to charge you $35. Now comes the part that's a little tricky. So how in the world do I get this next piece? So for the first 4 hours, I pay $35. So $35, but then up here we were adding in 20. And this would be 20 times 1 for that 5th hour. And then this would be 20 times 4 for the 8th hour. So we need, 8 hours, this 4 right here, that part is a little bit tricky. So like, how did I get 4? Well, this number here ends up being like 8 minus 4. All right, so 8 hours, but the first 4 are already taken care of. So I need something. I'm going to multiply this $20. I'm going to do this. I'm going to try to do a black one and that one. Okay. So the 20, oh, that was weird. I think that's because it's a pencil. All right, whatever. Just do this all right. So 20 times, well, it's the amount of time minus the 4 hours that have gone by already. Most of the time this will be written for you. We're only writing one because then it connects to the parking rate. So what we need is whatever time we have, so like 8 minus the 4 hours that have already gone by. All right, so what does this work for? So this will be good from 4 is less than or equal to x, which is less than, so this is where we kind of have to do a little bit of guess and check. So like what happens, at 5 hours, it's still good. At 8 hours, we're a little over $100, right? So what happens at 7 hours? So is 7 hours under that? All right, and we can also try to be like 7 point something. We're gonna not do decimals on this one. We're gonna say we're gonna round to the nearest hour for like all of these things for this problem in particular. So if it was 7 hours, does that work? So what would 35 plus 20 times, well, 7 minus 4, so another 3 hours. So 35 plus, so 20 times 3 would be 60. So that would be 95. So we're still under at 7 hours, the $100 max. Okay? But the second we're beyond 7 hours, we're going to be up here 20 more. So if I add 20 more onto the 60, we would tick up over $100. So the last one would be $100. Now what is this going to work for? So if x was 8, which we showed up here, we would get $100. It wouldn't be 115, it'd be 100. So if x is greater than, I'm going to put this on the left-hand side just so that they're all kind of in the same order. So 7 is less than x. So anything bigger than 7, like 8 or more, then we would use just $100. Now, in reality, there probably would be something along the lines of a 24 here on this right side, because that would be a full day. And if your car is sitting in that parking garage for more than a day, it's probably getting towed. But as far as our little sign here goes, it doesn't really say. It just says each additional hour is $20, maximum daily charge is 100. So then there becomes a question, what happens after a day? So in reality, you probably don't want to find out. So we'll just do this for a day. This might tick over for the next day as well. You get another 23 hours for the first 2 hours of that day, maybe. Or maybe you immediately get charged another $100. I'm not sure. You would have to ask the garage on that. So I will feel like this line right here is going to be the trickiest one, especially with this part, the x minus 4. But for most of the problems, I'm going to give you the equation, not so much that you have to write it from the data. But just wanted to do one where it was more like what you would see in real life. So the equation may be tricky. Actually using it's not that bad. Okay? So let's go to our notes and talk about how do we use this in terms of notes and all of that. All right, so jump on to page 32. I want you to pause this and see if you can answer the question, example 1. Find the rest of these values from the graph, and then we will do the next couple together. But try the first example, pause this, try it out, resume it once you've tried the problems. All right, hopefully you did it. So f of 1, if you don't remember, these are x's. So we go over to x is 1, and we figure out where the graph is. Now there's two choices. One's an open circle, and one's a closed circle. So we're going to use the closed circle on this one. So my value is just 1. The open circles, remember, that means that the graph is not actually there. Closed circle means where the graph actually is. So at 3, we go over here, and my graph is up right there, and that is a value of 3. That one doesn't have too much of a controversy, but for 4, or for 2, if I go up here, there are two choices. There are two spots where my graph is kind of hitting that axis 2. 2 or 3, well, I want the solid one, so my answer is going to be 3. And then for negative 2, you just go over to negative 2 and find your graph up here at 4. So if there is a choice between an open circle and a closed circle, we're always going to go with the closed circle because that's where the graph actually is. And this is what a piecewise defined function looks like visually. A lot of times they jump around. So like you have a parabola piece, you got a horizontal line piece, and you got a regular line piece. There are 3 pieces. This graph is defined piecewise, so it'd be a piecewise graph. Now, it could be visually, or it could be in terms of equations. So for our next example, I want to find f of negative 3. So there are 2 equations. There's an x plus 3, and then there's just a straight up 2. We just got to figure out, where does negative 3 fit? Well, negative 3 is going to be less than negative 1, because negative 3 is less than or equal to negative 1. That is true. Is negative 3 greater than negative 1? No, that is false. So we are going to use the first equation. So because this is true, that means we're using that. So my equation would just be x plus 3. So negative 3 is my x, plus 3, which would give me 0. So we're just evaluating functions, but we have to figure out which part of the equation to use. So it's kind of like we use this when time is less than negative 1. Doesn't really make sense in terms of the garage one because of the negative, but like you could think of the negative 1 as just like 1 hour. So under 1 hour, we use this equation. Over 1 hour, we use the second equation. All right, now negative 1 is the tricky one. Where does it belong? So is negative 1 less than or equal to negative 1? Or is negative 1 greater than negative 1? Well, because of the equal sign, we're using, again, that first equation. So that's true. So negative 1 plus 3. Negative 1 plus 3 is the same thing as 3 minus 1, which is 2. And that would be our value. All right, last one for this example. X is now 4. All right, it's the same question. Does it go into the first one? Is 4 less than or equal to negative 1? Or is 4 bigger than negative 1? And this is the correct one now. So 4 is definitely bigger. So we're not using the first x plus 3. We're just using the 2. And there's not much to do with 2. So the answer is just 2. All right, for our second example, I want you to pause it and try it. So pause the video, see if you can figure out where all these go, and then once you've tried the problem, then I'll go through the answers. All right, so for the first one, x is 5, and 5 is definitely bigger than 4. So we plug in 5 into the equation. So 5 goes in for x, minus 4, plus 1. 5 minus 4 is square root of 1, plus 1. You feel free to use Desmos, you feel free to use a calculator. Square root of 1 is 1. 1 plus 1 is 2. That's it. Now the second one is sneaky. So if you like, first one, third one, no problem. And the second one's weird. Because is 3 greater than or equal to 4? No. Is 3 less than 3? No. So this one doesn't have a spot. There's a gap between 4 and 3. So like 3.5 isn't going to be between these. So this one doesn't have a solution. That's actually the easiest one. It doesn't fit. There is no value of x that, if x is 3, 3 is not bigger than 4, and 3 is not less than 3. So there's nothing to work with. But the last one, negative 1 definitely is less than 3, so that'd be my second equation. The first equation, if I try it, is negative 1 greater than or equal to 4. No, that doesn't work. But it does work in the second. But by B, you can tell that sometimes it doesn't actually work. So what do I get? You get a negative, negative 1 plus 4. Again, we're just plugging in this for x in the equation. So two negatives make a positive, so this would be 1 plus 4, which would be 5. All right, normally I'd ask for questions, but since this is a video, if you have questions, I would just rewind it and try to watch it again and see if that makes more sense. All right, flip the page over, and now we're back to a little bit more real-world problems. But these are usually pretty easy, actually. And they look crazy, but they're not that bad. So we've got a cost for t-shirts. So the $10 charge. So $10 charge, and then if we have a couple different numbers of t-shirts, so X is the number of t-shirts. That's the other thing to kind of like note. X is the number of t-shirts. So X is somewhere between 0 and 100. So if we sell a small amount of t-shirts, we have our $10 charge, but they're going to charge us a little bit more for shirt if we don't sell a lot of shirts. If we sell more shirts between 100 and 350, then that price per shirt went down to 4. That's kind of what's going on here. So if you buy it in bulk, they still are going to charge you $10, but the per t-shirt goes down each time. All right, so what does that mean in terms of these problems? So first one's 85 t-shirts. So 85 was X. So we got to figure out, where does 85 fit? Well, 85 is definitely between 0 and 100. So we're using that first equation. So our answer would be 10 plus 5 times 85. Now we need a number. So we pull out some sort of calculator. 10 plus 5 times 85. So it would charge us $435. If we're going with 350, you got to figure out, where does that belong. So 350 is less than or equal to 350. So if you're hitting one of the edges, you got to look for where the equal to sign is. So that one's on the second equation. So our answer would be 10 plus 4 times 350. So you just got to figure out which equation does it work with. It works on the second one, and then you plug that in. So I'll just write it again. 10 plus 4 times 350. 1410. And then you should pause this and try the next part of it if you have not. So whether you pause it or not, 556 definitely fits in this last one, because 556 is bigger, greater than 350. So then we just plug it into the last equation. 10 plus 3.5 times 556. And then we go to our calculator. That's not the right button. 10 plus 3.5 times 556. Ooh, that is not quite right. There we go. So 1956. So $1,956. All right, I'll work backwards. So this is a little closer to the garage one. So because of that, we have to read a little bit more on this one. All right, so G Cell Company has different text message plans. If you text 250, messages are less a month. Your cost is a basic fee of 5 plus 0.07 per text. All right, so I'm going to start with this 5 plus 0.07 per text. So 5 plus 0.07. Since it's per something, we're going to put like an X on there. All right, so it's very similar to the 10 plus 5X. The comma, that's not that necessary, but if you want to put a comma here, that's great. As long as there's kind of space and you can tell what the equation is and what the condition is, cool. So if you text 250 or less, all right, so our texts are X, and they've got to be 250 or less. So if we're less than 250, now the only thing here is we really should have probably 0 as well, because you can't have negatives. You can't text negative number of messages. So 0 would be the smallest number of messages up to 250. We are going to be using this equation. Now the next part you're going to see is if you're between 250 and 1,000. So I'm going to put that over here. So 250 is less than, well, let's talk about the equal sign. Less than X, which is less than 1,000. Okay, so let's talk about the equal signs in a second. And then my new equation here would be 5 plus 0.05. So we get a little bit of a lower rate. So it's still $5, but then they're only going to charge us 5 cents per text. And then the last part, so like the 250 can't be in both spots. So let's talk about the equal sign. So 250 can't be both here and here. So the equal sign can only be in one spot. Now between in English could mean that you want to count that number or not, but I know the 250 belongs in the last one, in the first one. And then the last one starts talking about if it's 1,000 or more. So that is 1,000 or more. So I want 1,000 less than or equal to X. Now there is no upper end on this. You could also flip it around and be like X is less than, write it as X is greater than or equal to 1,000. Doesn't really matter. Both ways work as long as the alligator wants to eat the X. Right? That is the same thing either way. If you keep the 1,000 on the left, it kind of keeps the same pattern. Like the right number goes on the left, the right number goes on the left. So I would go with this version. But then it'd be a flat fee of 60. So this would just be 60. A little comma. And then you just got to figure out where these all fit. So if you need to rewatch that again, feel free to back it up and try to watch it. But try to understand why all of these numbers are where they are. And then all we got to do from there is figure out where they fit. So if it's 753, that would be here, because that's between 250 and 1,000. So my equation would be my equation for that second line. 5 plus 0.05 times 753. And figure out what that is. 5 plus 0.05 times 753. So 4265. And then the last one's going to be really easy because we're over that 1,000 mark, right? At 2,200, we are bigger than 1,000, and so our answer is just straight up $60. So that's our unlimited plan, basically. So if you're going over 1,000, if you know you're going to go over 1,000, we're just going to charge you that straight up $60. All right, what do we got after this? So what we got after is some homework. So page 34 and 35 would be homework. 36 has got this little problem that probably would have been homework if there was a picture going with it. All right, so probably going to have a little bit more practice for you, but your homework will be both page 34 and 35. So feel free to watch the video as much as you need to, but that would be the next step, would be your homework, and then check in with the sub, because as of this point I have not gotten any extra practice going for you guys, but there probably is a little bit more practice. I just have not decided on that as of recording. All right, thanks guys.